Hey there everyone! So today we are talking about factoring and percents, especially in this video, but how to factor and what to do to factor most efficiently depending on different things that come up, and how to deal with percents, especially word problems that involve percents. And then on top of that, we'll be looking at in the next video, how to divide with polynomials and divide with different terms that can become really tricky. Fractions become weird, and fractions are division. And so we're going to get into all of that and really find ways to make this as simple and as clean and easy as possible. Now, these things are kind of things that you really want to pay attention to, because these are things that you can almost guarantee will be on the test. Fractions and percents, maybe, maybe not. I hope, I don't know entirely sure. I'm not 100% sure. Could be on some tests and not on others. But factoring, I'm almost certain you'll find factoring. I'm almost certain you'll find different kinds of division. So let's jump in and see if we can find some ways to really knock these out and to do them well. The first one is factoring. And there's two different ways to factor depending on what you're looking at. Not many people tell you that, but depending on what you see, there are different rules. If it's and the major distinction is whether or not it's a quadratic equation or it's not a quadratic equation. Cool. So a quadratic equation, as you may remember, is something that has x squared or n squared or q squared inside of it. Maybe not so q to the second power, n to the second power. Maybe not n to the third power or to the fourth power. They'd make it a cubic or a quartic or other stuff, weird stuff like that we don't need to get into. But if it has something squared, then you know it's a quadratic equation and it's going to deal with different things. Let's see what happens first if the highest term is squared. Let's see what happens first if the highest term is not a squared, if it's something else like a fifth or just x or just q. Let's look at that first, and then we'll get into what quadratic equations do. So if it's not a quadratic, the way to factor it is by doing something called finding the greatest common factor. In order to get the greatest common factor, before we delve into it, let's first really lay some ground rules. In order to get factors, we got to talk about something called terms. A term, when I say the word term, all I'm really saying is just anything that's separated by a plus or minus. That's the kind of rule of thumb to deal with. Anything that's separated by just a plus or minus. So for example, it has a plus or minus next to it, and this has a plus or minus. 20n squared has a plus or minus has a plus next to it, and it separates the 30n to the fifth. These are two different terms because there's that plus in the center that's separating them. So we have two terms here. Okay, ground rule set, that's a term. The first step is to put everything in parentheses. So that's what we'll do. We'll lay up some parentheses, and we will put 30n to the fifth in one end, and on the other end we'll put 20n squared. That's the first step. That's all we're going to do. Easy peasy, just put some parentheses in. The second thing we do is we just divide stuff out from 30n to the fifth and 20n squared until we can't divide anything else. But remember, here's the big rule. If you divide into one term, you gotta divide into the other term as well. Here's what I mean by that. So I gotta divide both these terms by some number that can divide into both terms at the same time. So for 30n to the fifth and 20n squared, well, I could probably divide them both by 2. They're both even numbers. 30 and 20 are both even numbers, so I can divide them both by 2. So here's what I'll do. The second step says pull out a 2 of the parentheses. Actually, let's make the 2 a different color. Let's make the 2 an orange, so we're not just confused here. And then we're going to divide both terms by that 2 that we just divided out, that we're pulling out. So I'll take 30n to the fifth and divide that by 2. And then I'll take 20n squared and divide that by 2. And divide that by 2. Okay. So, and that's not, I think we can accomplish that. So 30n to the fifth divided by 2, that's 15n to the fifth. So what we're left with is 2 times 15n to the fifth plus 20n squared divided by 2. That's just 20 divided by 2 is just 10. So 10n squared. Okay. So let's see, we've done that. Is there anything else we can divide out? Well, I could divide out, let's see, we got a 15 and a 10. I could divide both those by 5. Those are both divisible by 5, so I'll divide them both by 5 as well. Here's what I'll do. I'll multiply the 5 by the 2, since I'm pulling out both of them at the same time. I've pulled out both those now, so I'll multiply them together. Anything else you pull out, you gotta multiply. And I'll divide those out. So I'll get 15 n to the 5th divided by 5 and plus 10n squared divided by 5. Okay, let's see. That gives us, I'm gonna just move on up here. And we will get, let's see, 5 times 2 on the left side is 10. So we'll get 10 times, let's see, that's 3n to the 5th plus 2n squared. All right, cool. So now I got 3 and 2. There's not really any number that I can divide out of both 3 and 2 at the same time. I mean, I can divide 1, but you can always divide 1, and that's not really going to be helpful. So you can always divide 1 out, and you can divide that a bajillion times, but that's not going to change much of anything. Actually, let's do it. Let's show you. 1 doesn't really do much of anything. So I can divide both these by 1 and say, let's see, I'll do 10 times 1, and then I'll do 3n to the 5th divided by 1, and then 2n squared divided by 1 plus 2n squared divided by 1. And that just gets me, well, 10 times 1 is just 10. And then 3n to the 5th divided by 1, that's just 3n to the 5th. And then 2n squared divided by 1 is just 2n squared. So this equals the same thing as this. They're both the same thing. Taking out a 1 does nothing, is what I'm trying to tell you. So it looks like we're done, except one more thing. We don't just divide out numbers, we can also divide out letters if we can. Let's see what letters we can divide out. Let's see, we've got an n to the 5th on the left and an n squared on the right. So that means I can take out 2 n's on both of them. I can pull out two, they both have 2 n's in common. The 3n to the 5th has 5 n's, and the 2n squared has 2 n's. So they both have at least 2 n's in them. I can pull out 2 n's, or more accurately, n squared. They both have 2 n's being multiplied together. 10n squared. So I can pull out an n squared. So I'm going to multiply by 10n squared. And then I'm going to divide both by n squared. 3n to the 5th divided by n squared. And then I'm going to add to that plus 2n squared divided by n squared. N squared. There we go. Okay. So let's see, that divides out. Let's see, 10n squared is just 10n squared. 3n to the 5th. 3n to the 5th divided by n squared. Remember, when you do division, you've got to subtract the exponents. The way to think about that, if you want to go to an aside and really be complex about it, n to the 5th divided by 3n to the 5th divided by n squared. What we're actually doing here is we're doing, at the bottom we have n times n, because that's n squared, that's what n squared is. And at the top we have 3 times n times n times n times n times n. I really want you to make sure you understand this, because this is vastly important. And in the process of subtracting, in the process of division, we just cancel out some n's. These n's cancel out, those n's cancel out, and we're left with 3 times n times n times n, which is the same thing as saying 3n cubed. So n to the 5th divided by n squared, 5th divided by squared, 5 divided by n to the 5th divided by 5 to 2 is 5 to, n to the 5 divided by n to the 2 is n to the 3. 5 minus 2 is 3. So this is 3n cubed. All right. Same thing with the 2n squared divided by n squared, except they're the same thing. N squared divided by n squared, those just cancel out, because they're the same. N squared and n squared are the same thing, so they just cancel out the 1. So plus 2. Okay. Well, great. And remember, when n squared divides with n squared, they don't divide out to 0 or anything. They don't get rid of each other. N squared divided by n squared, it's like 5 divided by 5. That equals 1. N squared divided by n squared, that is 1. So what we get is 2 times 1, and 2 times 1 is 2. That's why there's a 2 here, not something else. We're not getting like 2 times 0 or something. This is just 2. Okay, great. So, and is there anything else we can pull out? I think that's it. That's all we can pull out. So if that's all we can pull out, that is our answer. Now, as you do this more often, we took quite a while to get this done, but once you get the hang of it, you could do this problem in seconds, well under a minute. It's just the process of getting used to what you need to do. So, but that's the process. That's the full process. The second problem is in factoring is the second kind of problem is if you get a quadratic. If a quadratic equation and you need to factor, then you'll want to use some other method than this, because this method we just used isn't really going to be so helpful. You can't pull numbers out so easily. So we'll use a different method. We'll actually use what's called the AC method. There's other methods that work, but this is what we've talked about in class the most. So this is the one I'm just going to show you how to do again. Okay, so the AC method. With the AC method, we start off. Let's recall first what a quadratic looks like. A quadratic comes in this form of ax squared plus bx plus c. What this means is the number is c, the number that's all by itself is c, the number, positive or negative, this one's negative, that's next to n, or next to just something without a power next to it, is our b, and the number that's next to n squared or x squared is a. Cool. We need to know that in order to get into the AC method. So just to start off, we can see that a equals 10, b equals, we'll actually include the minus there. That minus is helpful. So we'll actually say minus 31, and c equals 24. Okay. Now here's where the AC method comes in. This is why it's called the AC method. We'll draw a giant X, because X marks the spot, I suppose. And at the top, we'll write the letters A times C. A times C. And at the bottom, we'll write just B. If you're fancy, you can remember that A times C, or AC, literally means A times C. But that's another discussion for that time. AC. So write AC at the top. And because there's a multiplication up here, we can write a little multiplication down here as well. Just remember that's multiplication at the top. And at the bottom, we'll write this plus sign. Just to remind us that there's a plus sign that we're going to add for B. That'll come in later. Okay, so at the top, we'll write A times C. We'll take A and actually multiply it with C. So 10 times 24 is 240. Okay, and for B, we'll just write B in, whatever B is. And B is negative 31 in this case. So here's our assignment now. Our assignment is now to find two numbers that multiply to be 240, but add to be negative 31. That's our next step. And to do that, we will need to do a couple things. This is a tough problem to do, because what number is multiplied by 240 and add to 31? What number is multiplied to 240 at all? In order to accomplish a really difficult problem like this, what I usually like to do is what's called a table. I like to make a table of multiplication that tells me how all the numbers that can multiply together to be 240. Here's what I mean by that. Here's how I'll do this. I'll write 240 at the top, because that's the number I want to multiply to. And underneath it, I will make a little table here. And because I want to find all the numbers that multiply to 240, and I want to figure out if I can combine them in any way to get to negative 31. So let's see. What's the numbers that multiply to be 240? Well, the easiest one is just 1 and 240. That works. Now here's the question. Can I do a plus, a minus, a multiplication, or a division of 240 to equal negative 31? or to equal 30, even just 31. And it looks like, let's just go 31. And it looks like, no, I can't. If I subtracted 1 and 240, I get negative 239. If I multiplied them, that'd be 240. If I divide, I'd get some other, I would get some other really small number. So there's really no number, there's no operation I can put here to make 1 and 240 equal 31. So I gotta keep going. I gotta try a different number. Let's try 2 and 240. Well, let's say try 2. Well, 2 divides into 240. Say 240 divided by 2 is 120. Let's try that. 2 and 120. Do those together equal 31? Is there any way I can combine those? Well, no, there's no way I can combine those either. So that's not going to work. Let's keep going. How about 3? Does 3 divide into 240? It does. It divides into 80 times. And I can keep going. 3 and 80, there's no way to get that to 31. So there's no way to combine that. And we'll just keep going. So 4 and 240, I can do 60. And I'll tell you from the get-go, 4 and 60, there's no way to combine those to get 31. So we'll keep going. 5 and 240, that 5 goes in 240, what is that, 48 times? But that doesn't combine anyway to get 31. 6 and 240, that goes in, let's see, that's 40 times. Now I can combine that to get really close. I can get to, let's see, 6, 40 equals 31. I could subtract 6 and 40, and I'll get to 34. So I'm getting close, but it's not 31. Not 31. So it's still not there. It's not where I want to be. So I got to keep going. 7. Is there any way to combine 7? No, there's no way to combine 7. I can't. 7 doesn't go into 240 at all. No, so I'll just skip 7. Let's try 8. 8 goes into 240 30 times. There's no way I can combine that to get 31. Let's see. 9. Does 9 combine in? No, 9 doesn't work. 10. I don't think 9 works. Does 9 work? No. No, it doesn't work. It doesn't work. 10. 10 goes in 24 times. But there's no way I can combine 10 and 24, so I gotta keep going. This is a tough problem, as you can see. And this is really, essentially, you can pick random numbers, I suppose, but I think this is one of the most, I've chosen a really tough problem to kind of demonstrate this concept to you, but most problems would be perhaps a bit easier than this. But this is probably the fastest way of getting to the answer if you're unfamiliar with if you don't have your own method that works well for you already. Okay, 11 does not go into 240. 12 does go into 240. 12 and 20 go in, but I can't add, subtract, multiply, or divide 12 and 20 to get 31, so I'll keep going. Let's see, 13. I don't think 13 goes into 240. And I don't think 14 goes into 240 either. No, it doesn't. So, but 15 goes in. Let's see, 15 times what? 15, I think 15 times 16 goes into 240. And let me try that, I can write that out. 15 times 16, that gives me, let's see, that's 30. Carry the 1, that's 90. Now put in the 0, 15. Add that gives us 240. Yeah, 240. There we go. Great. 15 and 16 go. And that's like the last of my possibilities. So can I combine 15 and 16? Let's see. I could add them. 15 plus 16 equals 31. So those are our numbers. Great, we've got the numbers now. Don't you hate it when your camera dies on you? That's no fun. All right, to get back into it, so I've got two options now. I can either write a plus or a minus in between the 15 and the 16, and I can make 15 and 16 either positive or negative. So I can make 15, let's see, I can make 15 negative and 16 negative, or I can make 16 positive. And I can put a plus or minus in here. Or here's what I can do. I can take 15, I can do 15 and 16, or I can just choose a positive 15 and a negative 15 and positive 16, or positive 16 negative 6, positive 15 negative 16. I can use them both to be positive, both to be negative. I can do any combination, but I've got to make it so that they multiply to be 240 and add to be negative 31. So if I do 16 and positive 15, that multiplies, let's see, 15 times 16 equals 240, so that's good. But 15 plus 16 equals positive 31, and I want a negative 31. So that's not quite going to work. If I chose 15 and negative 16, negative 15 and negative 16, and negative 16, well, that multiplies. Negative 15 times negative 16, that multiplies to be negative 240, and that adds to be, let's see, negative 15 plus negative 16, that equals to be negative 15 times negative 16, that equals positive 240. Sorry, quick correction there. And negative 15 plus negative 16 equals to be negative 31. So that's good. These are our numbers now. These are our special numbers. So what we'll do is we will rewrite the problem with that as our b. Here's what I mean by that. We'll write the problem as before, exactly as it was before. So let me go ahead and rewrite it. We're going to go ahead and choose 10n squared and then 24. But instead of the minus 31n, we're going to write minus 15n and minus 16n. Now you might be saying to me, no, Mr. Jurczyk, that's a problem. This looks like it's more confusing than it was before. Don't worry, I'll make it simpler for you. This is gonna be much easier in the long run. So just trust me here. This is gonna make it easier. So we've got 10n squared minus 15n minus 16n plus 24. You can check to make sure this still works, because minus 15n minus 16n, that combines, that equals minus 31n. Those combine to be negative minus 31n, and that's what we had before. 10n squared minus 31n plus 24. So let's continue. The next step is to make parentheses. So we'll go ahead and do, let's see, 10n squared minus 15n, and we'll put some parentheses around that, and we'll add to that the other parentheses. Let's see, and that is minus 16n, and then plus 24. And here's what we'll do now. We will factor this in the same way that we factored the first problem. Exactly the same way. We're going to pull out whatever terms we can pull out. So on the left side, I'm going to pull out everything I can pull out. The greatest common factor, I'm just going to do this quickly for you, is 5n. I can pull out a 5n on both sides. That divided out becomes a 2n on the left and a minus 3 on the right. And so let's see. And on the right side, I want to pull out a number so that I get 2n minus 3 on the other side. And so what number can I pull out so I get 2n minus 3? Well, I can pull out a negative 8. If I pull out negative 8 and divide that out on both these terms, I'll get a 2n minus 3. If I pull out a negative 8, that'll get me a, let's see, negative 16n divided by negative 8, that is 2n. And then 24 divided by negative 8 is negative 3. So I divided this by 8, by negative 8, to get the same number. So this equals that. That's what I was trying to do this entire time. Okay, now that we've got this, the answer is almost there. It's almost there. We just got to combine it together. So the stuff on the outside of the parentheses, this is our first answer. So we get 5n minus 8. That's our first answer. That's our first bit. And the second bit is just stuff that's inside parentheses. 2n minus 3. And that's it. That's the full answer. This first bit becomes the first part of the answer, 5n minus 8. The stuff outside the parentheses is the first part of the answer. The stuff inside the parentheses is the second part of our answer. Okay, great. And that is how you factor those problems. Okay, let's move on to ratios and percents. This is a little bit different than what we were talking about before, but it also you might end up doing a little bit of factoring here and there, so I've presented it second. So let's look at it. It says, what percent of 35.3 grams is 124 grams? Now, immediately this looks confusing and it looks scary, and it's like, what's going on? How do I solve a problem like this? Because it looks like there's a whole ton of stuff going on. It looks like a word problem. I don't know how to do a word problem, but don't worry. It's not really a word problem. It's a word problem. It's a math problem in disguise as a word problem. And we just got to convert it back to a math problem, and then it'll become much easier. Here's the way to convert it back to a math problem so it becomes super easy. You just got to take it and say, whenever you see what, you replace that with X. Whenever you see percent, you use a percent sign. Whenever you see of, you put a multiplication sign. And whenever you see is, you put an equal sign. Whenever you see a problem like this, any problem you see, do this. Just change these words into these. Just change the words into these symbols, and that'll make it so much easier. Okay, so what is X? So we get X percent of is times 35.3 grams. We can just forget grams because it's all the same units anyway. Is equals 124 grams. And that's it. That's our problem. So we get X percent times 35.3 equals 124. And that's the problem. If you want to make it even easier on yourself, you can say that percent actually means divide by 100. That's what it actually means. And that's the second step, is just replace the percent sign with divide by 100. So we could say X divided by 100 times 35.3 equals 124. And you can do this. You can probably figure out what to do from here. Let's see. We'll get rid of that. We need to get X all by itself. So we'll get rid of that 35.3, the stuff that's furthest away first. And I'll get rid of the stuff that's next to it last. So to get rid of 35.3, we divide both sides by 35.3. Divide by 35.3, divide by 35.3. And you'll notice, it's important to notice, this is the left side. All of this is one term. Normally, you would, when you divide both sides by number, you divide every term by that number. So if this is multiple terms, I would divide. If this was like, if this is multiple terms, I'd take each term and divide it by 35.3. But because there's no plus or minus signs, this is all actually just one giant term. So I only do one division. It's important to remember that. You do one division for every single term that's there. Okay. So let's see. 35 divided 35.3. These cancel out. 124 divided by 35.3. Let's see if I got my calculator here. Looks like I might need to pull it up again. There it is. So 124 divided by 35.3. That is a simple 3.512. That gives us 3.512. So that's X divided by 100 equals 3.512. And let's see, X is being divided by 100, so I gotta do the opposite of that to get rid of the 100. I gotta do the opposite of division. So I'll do multiplication. Divided by 100 times 100. And times 100. These cancel out. So we're left with X equals, let's see, 3.512 times 100. I just move the decimal place over 2 times. And we get 351.2. Okay. And that's our answer. 351.2. That is the answer. If you want to be fancy, you could say 351.2 grams. And in fact, that's a little more official because they gave you grams. And so maybe this one would actually be a little bit more recommended. So I'll put a box around that one. But really, that's the answer. You just turn it into a math problem and solve it that way. Okay. Now let's say you're trying to find the percent difference. This is the other kind of problem you'll see. You want to find the percent difference from one number to another number. Again, it's a really straightforward process. You just got to follow the process and you'll be good to go. We're going to subtract the end value from the start value. So this is the end value. The second value is the end value. We ended here, we started here. So we went from 24 meters to 19 meters. We started with something that's 24 meters long, and now we're going to 19 meters long. We're trying to figure out what the percent change was. So we subtract that end value. First, we got to figure out is how much was that change? How much did it actually change? So we'll take the end value and subtract the start value. So we get 19 minus 24, and that equals a negative 5. That's step 1. Step 2 is we divide that answer that we get from step 1 by the start value, the beginning value. So we get negative 5 divided by 24. Divided by 24. So we changed negative 5. In other words, we lost 5 meters. We got 5 meters, went from 24 meters to 19 meters. So we got 5 meters shorter. We lost 5 meters. And how much is that loss compared to the whole thing? Well, that's a loss of 5 of 24. So negative 5 divided by 24. We're just going to just divide that out. So we'll get back to the calculator. So negative 5 divided by 24. That gives us, oh gosh, oh yes. That is, sorry, I thought my recording was off, is negative 0.208. That would have been so unfortunate if the recording was off. And so that gives us was negative 0.208. Let me make sure I got that right, because I don't want to make mistakes here. Yep, okay. And then from here, we just write that as a percent. If you remember how to write percents is to change a decimal to percent. You just move the decimal value over 2. You move the decimal over 2, and then you add a percent sign. So 3 equals, or in other words, multiply by 100. So we'll move the decimal value over by 2. So we had negative 0.208. We're going to move the decimal value over 2. And so that gives us, that equals negative 20.8, and we'll add a percent sign. That's all you got to do to change from a decimal to a percent. The turn from a percent to a decimal is just like we did up here. We divided by 100. See, we divided by 100. We turn from a percent to a decimal. That's the way to do that. Okay, and finally, we just look at the sign. The fourth step is look at the sign. If the sign is negative, like it is here, then it's a decrease. We went from 24 to 19, so we lost some. If it's not a negative sign, there's no negative sign, then it's an increase. So we lost some in this case. We had 20.8% decrease. Cool. And that would be our answer. Now, if you run into any more problems with these particular problems, just let me know. I'd be happy to help you however I can, as always. Please let me know how I can help. The next video, we'll talk specifically how to do the other kinds of problems we have for this week, and that's just division and weird division with polynomials and all that sort of stuff. So I've separated that into a second video so you can kind of see that more easily. But good luck. Let me know how I can help you. If there's any way I can help make these videos more clear for you, so in the future I can make this even more helpful than before. Thanks.